All right, here we are, back at it again, doing a little bit of Algebra, Chapter 3, this time combined lessons 1 and 3, graphing linear equations, rate of change, and slope. So, a linear equation is an equation that forms a line, linear line, get it? The variables in the equation must be raised to the power of 1. That means none of them will have an exponent of more than 1. So if you see x squared or y squared, that's not a linear equation. Standard form is when it's in the form of something x plus something y equals a number. So ax plus by equals c. For example, you could see 3x plus 2y equals 5. Okay? A, b, and c are integers. A and b can't both be 0. And c is called a constant. So, determine whether this is linear. Any linear equation can be written in standard form. So I can add 3x to each side, because remember x and y have to be on the same side for standard form. Add 3x here, then we get 3x plus 1y equals 4. That's in standard form. So this is a linear equation. Can we change this into standard form? No. X and y are being multiplied with each other, so I can't write that in the form of ax by equals c. The x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. Notice at the x-intercept, the value of y is 0. At the y-intercept, the value of x is 0. To find the x-intercept, we'll make y 0. To find the y-intercept, we'll make x 0. So here we go. To graph this by using the x and y-intercepts. Remember, to find the y-intercept, we'll make x 0. Go ahead and pause your video and try to do that. Find the x and y-intercept. Okay, so this is what you should have. If you didn't do that, pause it again and solve this. Fill in 0 for x. This cancels out. 2 times 0 is 0. So then we have 4y equals 16. Divide by 4 on each side. And y is equal to 4. So the y-intercept is when y is equal to 4. 1, 2, 3, 4. Right here. The x-intercept, where it crosses the x-axis, this cancels out. 4 times 0 is 0. Divide by 2 on each side. And then you get x is equal to 8 at the x-intercept. So 1, 2, 3, 4, 5, 6, 7, 8. Since this is a linear equation, I can draw a straight line through these 2 points. Okay, to graph it by making a table, now you can plug in any values for x here and get something out for y. I suggest using easy values, like 0, 1, and 2. Now, when you have a fraction as a coefficient, I say use the denominator and any multiples of it. 0 is always a good one, so we'll put in 0. And then 3, that's the denominator. And 6 is a multiple of that denominator. That way I can always cancel out the fraction somehow. So if I plug in those values, I get these 3 points. So there are the 3 points, and then we can graph a straight line through those points. That is a linear equation. Chapter 3, Lesson 3, we're talking about slope. Slope equals rise over run. Same as a slope. It's dope, that's fun. Rise is the change in y. Subtract points 2 and 1, that's right. Run through the horizontal plane is a change in x. Do you hear what I'm saying? There you go. So that is the slope. breakdown for you. Slope describes the steepness of a line. The greater the absolute value of the slope, the steeper the line. So m is the change in y over the change in x. How you find that change is up to you. I'll show you a little shortcut. A moment ago you saw those notes. You can subtract the 2 points. Sometimes when we have a negative value, we get confused and we forget that subtracting a negative actually gives us a positive. I'll show you the 2 ways to do this. The traditional way, m is y2 minus y1 over x2 minus x1. That gives us y2 is 4 minus 3, and then over x2 is 2 minus, careful here, negative 1. And this is where many of you make mistakes. We forget minus and negative. So that would be plus, and that would give us 1 over 3, not 1 over 1. Okay, here's a fast method. This is my trick that I've developed. I find fun, easy, useful, a fast way to do this. Remember, change in y is on top. So the change in y is, what do I have to do to 3 to get to 4? Add 1. What do I have to do to negative 1 to get to 2? Add 3. So I've got 1 over 3. That's the fast way right there. Here's a couple of examples. Try that out. Pause the video and see what you get. For example A, we go from 0 to 5. That's a change in 5. And from negative 2 to 1, that's a change in 3. So 5 over 3. This is the one place where we leave improper fractions, is the slope. From 4 to negative 3, I have to subtract 7. From negative 3 to get to 2, I have to add 5. Now, it doesn't matter whether the negative goes on top. That's the same as 7 over negative 5, which is also the same as negative 7 over 5. So it doesn't matter whether you go forwards or backwards when subtracting, which one you do first. Now, example C, we got to change from negative 1 to negative 1. We don't add anything or subtract anything, so that's 0 over, and here we have to add 5. 0 divided by anything is always 0. So notice if there's no change in y, gives us a 0 slope. So here from 4 to negative 3, we have to subtract 7 over from negative 2 to get to negative 2. We don't add or subtract anything. Careful, you cannot do this. This is undefined. Now just a quick visual of those. A positive slope, we always read from left to right. A positive slope goes up. That is when m is greater than 0. Negative slope is from left to right. It goes down. M is less than 0. A horizontal slope is when m equals 0. And a vertical line is m is undefined. Here are a couple of examples of that. These are the equations of these lines. Notice all of these could be rewritten in standard form. ax plus by equals c. In this case, a would be 0, so 0x plus 1y equals 4. And in this case, b is 0, so 1x plus 0y equals negative 4. Okay, if we want to find the value of r, if we know the slope and we're missing one of the coordinates, we could set it up as follows. We know that the slope is y2 minus y1 over x2 minus x1. And the slope is 1/3, so I can replace that, and then replace what I know. y2 is r, y1 is 4, x2 is negative 5, and x1 is 1. So now I simplify this, I'll get 1/3 is equal to r minus 4 over negative 6. Multiply each side by negative 6. This cancels out. Here we get negative 6 times 1 over 3 is equal to r minus 4. I can simplify here, divide each one of these by 3. I get 2 there and 1 here. So I'm left with negative 2 times 1 is negative 2 is equal to r minus 4. Add 4 to each side, and I get r is equal to 2. That should say 2 is equal to r. r is equal to 2. All right, so if I want to look at a table, see whether this is a linear function, I've got to make sure that the change, the rate of change of each of these, or the slope, is the same. So the slope is the change in y over the change in x. So look at the change in y, that's minus 2. The change in x is plus 3. Make sure that is constant for all of these. If it is here from negative 8 to negative 10 and 4 to 7, and it is for the rest of them. So yes, this is a linear function. Check this one. Look at the first two and see what's the rate of change there. The rate of change is 2 over 2, or 1. And then make sure that's the same for the next one. So from 10 to 12 we go up 2, but from 12 to 16 we go up 4. So this is not a linear function. Here we have a table to find the rate of change. Again, change in x, change in y. We look rate of change same as the slope, so we'll look at the change in y, 78 over 2, and then we could simplify that to 39. Check that, and it is correct. Remember to like it's your business.